Variations in the sun's output. Is there anything to be concerned about? Hello YouTube, Texas Renegade right here. I wanted to get this information out there in regards to this article that appeared on the internet on January 8th of this year, titled Solar Variability and Terrestrial Climate. In the galactic scheme of things, the sun is a remarkably constant star. While some stars exhibit dramatic pulsations, wildly yo-yoing in size and brightness, and sometimes even exploding, the luminosity of our own star varies a measly 0.1% over the course of the 11-year solar cycle. There is, however, a dawning realization among researchers that even these apparently tiny variations can have a significant effect on terrestrial climate. A new report issued by the National Research Council, The Effects of Solar Variability on Earth's Climate, lays out some of the surprisingly complex ways that solar activity can make itself felt on our planet. One of the participants, Greg Kopp of the Laboratory for Atmospheric and Space Physics at the University of Colorado, pointed out that while the variations in luminosity over the 11-year solar cycle only amount to 0.1% of the sun's total output, such a small fraction is still important. Even typical short-term variations of 0.1% in incident irradiance exceed all other energy sources, such as natural radioactivity in the Earth's core combined, he says. Of particular importance is the sun's extreme ultraviolet radiation, which peaks during the years around solar maximum. Within the relatively narrow band of EUV wavelengths, the sun's output varies not by a minuscule 0.1%, but by a whopping factor of 10 or more. This can strongly affect the chemistry and thermal structure of the upper atmosphere. Okay, so what we're talking about here is that Old Sol, our star, is or has been relatively constant within about 0.1%, except when it comes to extreme ultraviolet. Now that begs the question, does this increase in extreme ultraviolet radiation by a whopping factor of 10 or more, or one order of magnitude if you prefer, pose a hazard to the fauna and the flora on planet Earth? Well, I'm not saying that it does, but let's look just a little further here. If you've been watching The Suspicious Observer as I have, you are probably aware that our thermosphere has been shrinking or contracting. Now, the thermosphere is the thickest and the outermost layer of our atmosphere. Now, reading from Wikipedia under thermosphere. The solar X-ray and extreme ultraviolet radiation, XUV, at wavelengths less than 170 nanometers is almost completely absorbed within the thermosphere. This radiation causes various ionospheric layers as well as temperature increase at these heights. While the solar visible light is nearly constant with a variability of not more than 0.1% of the solar constant, the solar XUV radiation, or the extreme ultraviolet radiation that we've been talking about, is highly variable in time and space. For instance, X-ray bursts associated with solar flares can dramatically increase their intensity over pre-flare levels by many orders of magnitude over a time span of tens of minutes. So now we're talking about an increase of many orders of magnitude over a time span of tens of minutes during a solar flare over pre-flare levels. Just to clarify, an order of magnitude is times 10. 2 orders of magnitude would be times 100. 3 orders of magnitude would obviously mean times 1,000. So when the X-ray burst dramatically increases by many orders of magnitude from a solar flare, that means it is increasing by 1,000 times or more. Okay, let's look at one more article that gives just a little more information about what's going on with our thermosphere. This one is titled, Earth's Shrinking Atmosphere Baffles Scientists. Scientists are mulling over why part of the Earth's atmosphere recently suffered its biggest collapse since records began, and it is only now starting to rebound. The collapse occurred in a region known as the thermosphere, a rarefied layer of the planet's upper atmosphere between 90 and 600 kilometers, 56 to 373 miles above the surface, which shields us from the sun's far and extreme ultraviolet radiation. A report in the Geophysical Research Letters by a team led by John Emmert from the United States Naval Research Laboratory has found that the thermosphere went through its biggest contraction in 43 years. The thermosphere usually expands and contracts in line with the sun's 11-year solar cycle. During solar maximum, when the solar activity increases, It causes the thermosphere to heat up, reaching temperatures of 1100 degrees centigrade, and expands like a marshmallow in a campfire. The opposite happens during solar minimum. Okay, that previous article is from 2010. We have been in a lull of Earth-facing solar activity for some time now that has further contributed to the contraction of our thermosphere. A moderate amount of solar activity is beneficial since it fluffs up our thermosphere and increases our protection from the X-ray and extreme ultraviolet. You don't ever hear the mainstream scientists talking about potential hazardous effects to life on Earth from these solar events. Of course, they do say that the atmosphere and the Earth's magnetic field protects us, but when you get to looking around at the relevant information on the internet, some of which is discussed in this video, and when you consider that the Earth's magnetic field is in a state of decline, as evidenced by the Southern Atlantic anomaly, which is the recent weakening of the Earth's magnetic field over South America, as shown here. Back to the original question. Variations in the sun's output. Is there anything to be concerned about? Well, considering that the interplanetary magnetic field establishes periodic magnetic reconnections with the Earth's magnetosphere, resulting in giant breaches occurring in our magnetic protective field, it might be a bad time to be outside getting a suntan if the magnetic field happened to open up immediately after an X-level flare event had occurred.